All right. Okay, so moving on with our 5.2 note taking, we've got our extra practice going on. We just had a discussion about matching up and naming all the corresponding angles, and then we talked about how these triangles are both considered isosceles triangles because their side lengths, two of their sides are the same. So these guys would be isosceles. I'm just going to write that up there just as a reminder. Isosceles, ISOSCELES. Those are isosceles. Two side lengths are the same. I think they actually would be also acute. Let me just drop that in there because when we name triangles, we use a name for sides, we use a name for angles. Now, I want to work through these examples with you guys. I'm going to get some little stop off at points and see if there's places where people can participate. But we've got to use our algebra to figure out what the x and y values are. The directions tell us to get x and y. Now, what I'm noticing as I look to set up these problems is the y expression has to do with side lengths. And the fact that we've got 1, 2, 3, 4 side lengths are the same. You know I've got to basically pair up things from one figure to the next in order to solve for that y value. And so what I see going on is s to t is expressed as 3y plus 9. I'm going to jot that down there. And I'm going to write an algebraic problem, 3y plus 9. And I'm going to write an algebraic problem because this congruent statement is here. I can set that equal to 15. And then, yep, because there's the congruence mark. These sides are the same. So I'm just going, well, if this is 3y plus 9, then that all must be equal to 15. And then I'm going to just go through the process of solving this equation. There's nothing to simplify. So it's a matter of just undoing. Left with 3y, bring my equal sign down. 15 minus 9 is going to give me 6. Divide both sides by 3. Y is going to be 2. They didn't ask us to use it. They just said find it. So the y had to do with the sides. I'll give you a second there to finish that up. The y had to do with the sides. Now, the angles. I have 30 degrees sitting at angle S, and I have an expression related to X sitting at angle Y. And I'm noticing here we had already said that angle Y and angle S are congruent. We already said that by naming them when we talked about, the congruence, the corresponding parts. And so if Y is 2x minus 20, and it's congruent to S, then that means that 2x minus 20 must be equal to the measure of S, which is 30. So I'm looking at matching up. I already knew those were corresponding and congruent angles, and I'm going to match that up. And then to solve it, I'm going to add 20 to both sides. 2x equals 50. When I divide everything by 2, x is 25. What questions might you have right here before I go further? Anything? Go ahead, Dominique. It is obtuse. Good. It is. I saw the 30 and I'm like, oh, 30 degrees. She's fixing me up back here. Good. Just checking, seeing if you're paying attention. No. You're right. It's isosceles, or it's obtuse because the largest angle is greater than 90. I can tell by looking at it that it's bigger than 90. Actually, if this one's 30 and this one's 30, what do we got? 60. 60, those would be 130. So just using that angle, those guys are 30, these are 30. That would be 130 here. And I don't know about the side lengths because I didn't have to plug y in, but I could. Oh, the side lengths are all 15. I knew that. Just find y. We know the sides are 15. So what I want to do next is I'm noticing that, okay, so number 4. I'm just looking over what's number 4 dealing with. I'm noticing a couple things about 4. I've got a congruent statement, 4-sided figure. And as I look at, okay, I got to solve for x and y. So like just looking at your picture and think about what I'm saying here. When I want to solve for x and y are all, everything's related to angles. There's nothing about number 4 that has anything to do with sides. And so I think what might be the most useful for us right now before we go into 4 is exactly how we started number 3. Angle A, it's all related to angles. Angle A, angle B, I'm going to write down the congruent statements, angle B, angle C, angle D. So I just took these names, broke them down, these angles. Write their corresponding angles next to them. A, B, C, D, and I'm just going to match them up. A goes with E, F, G, H. E, F, G, H. So if we can write down those corresponding congruent statements, we know that these quadrilaterals are congruent, so then we break it down and be like, well, here's the angles that must be congruent and matching up with each other. That's what corresponding parts are, or the corresponding angles, which ones match with each other. And again, I just use the name because we had talked about over here about how the orientation of the figure might be weird. So I just looked up here. I didn't even actually look at the drawing. I just used the letters. It went A, B, C, D, so the matching ones must be E, F, G, H. You can always fall back on that. I have, in angle A, I've got 60 plus 8x. Angle A corresponded to which other angle? A went with E. Cool. I know that that's 108. So angle A was this. We knew it was congruent to angle E, and that's what led me to be able to set up this equation. What's the first thing I'm going to do? I don't have a calculator. I think it's 48. Yeah, pretty sure. And then what am I going to do next? Cool. Now, I'm going to start charging dollars every time I hear the word shut up. I got C, 62, angle C. Angle C was congruent to what other angle? Look at what we wrote. C and G. Sweet. Well, G's got some information there. So 62 must be equal to that 8y minus 3x. Ooh, this is interesting. It's got a y and an x. Did you guys notice that? Yeah, I didn't notice that until just now. So I actually had to find x before I could go over to find y. So before I do anything further, 62 equals 8y minus 3 times 6. I got to put the 6 in for x because I'm not going to be able to solve for both. I already know what x is. 62 equals 8y minus 18. I had to use my x. Now from this point, 62 equals 8y minus 18. Now I'm solving. I'm going to add 18 to both sides. I think that's going to be 80. And then I'm going to divide everything by 8. Y is 10. When you're ready to move on, turn your page, and that'll be my clue. I am holding. When you're ready to move on, turn your page. All right. Oh, we actually run this way. Okay, so now we got to show that this is going to be interesting here because we've got to show that I got marker on mine. I don't like how this looks. Let me grab another copy. You guys see how my paper's kind of weird? There we go. Here we go. This is better. Okay, so we need to show how the polygons are congruent and explain how we know. So like, I guess what we're trying to do is show that this triangle ABD is congruent to triangle BCB. So let's start talking about a couple things. We know angle A is congruent to another one from markings. What other angle has the same marking as? Yep. I'm just going to sort of mark, I'm going to just do this. Angle A and angle C are congruent to each other. I got to see how many parts of these triangles I have congruent. Ooh, I see another marking right here. Segment AB. What do you guys got on segment AB? Which one matches up with that? This one's got the same marking. Okay. I think you're getting ahead of a few people here, but that's okay. I see the double marks here. So AD, double marks on DC. Oh, this is interesting. This is interesting. And I think now, what's the property that we looked at on the first page that says, what's the marking that we looked up at the first page that says it is what it is? What was that rule? Remember the transitive, symmetric, all that stuff? What's the one that says it is what it is? Reflexive? Is that the one? Look back. Reflexive. Dominique's the only one that's like, what do we got this? Reflexive. It is what it is. Reflexive. Ooh. So you know what I want to point out here, you guys, and this might seem weird, because if we're going to show that these triangles are congruent, we've got to have all congruent parts. And then in a triangle, the parts are going to be 3 angles and 3 sides. Right now I've got 1 angle, 2 sides, but this is what I want to talk about right here. BD is the same as BD. Because, and I'm talking about it in 2 ways because it's on 2 different triangles. BD is on this triangle, BD is on this triangle. So there's my 3 congruent statements for sides. 3 congruent statements for sides. Let's, once again, it's like we've never, ever seen an emergency vehicle go by in our lives. Now, right here, and this is going to get a little more technical with angles. I see ADB, angle, I got to use all 3 letters now. ADB is 90 degrees. And if ADB is 90 degrees, I can make the assumption that CDB is also 90 degrees. CDB. So I'm getting there. I'm getting there. Right now, I have 2 angles congruent. Theorem 5.4, third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. It's a rule. Just a minute. So if 2 angles of one triangle, we've got 2 angles of one triangle congruent to 2 angles of another, then the third one is congruent. So I guess then this gives us the permission to drop those markings in and say that A, B, D, notice that's different, B is the vertex, is the same as C, B, D, angle C, B, D. Now back in our early chapter 1, naming sides and angles was something that I'm like, you guys need to know this, you need to be able to do this, and here it is. But you have to be able to show all the parts. You're missing a side. So in order to show that figures are congruent, you need to show that all the angles and all the sides are congruent. Now when we go over to number 6, I had 3 pairs of sides, 3 pairs of angles. In number 6 though, these are 4-sided figures. So I've got to show for 4 sides and 4 angles that everything's congruent. So we got to start just matching up. So let me get this out of here. 6. I'm going to make a little spot. I'm going to put sides here, and I got to see if I can come up with it. We're trying to, oh, it says explain your reasoning. Hold on a second here. ADB, triangle. ADB is congruent to ADB. CDB, triangle. CDB, because all pairs of corresponding angles and sides are congruent to each other. All pairs of corresponding angles and sides are congruent to each other. So this is, I'm showing all the pieces, and then I'm giving a little summary statement. Showing all the pieces and giving a summary. And then over here I want to see if I can match up 4. I think I can. I think that we've got enough on number 3. What did I call it? Number 6 over here. I think I've got enough. Let's talk angles first. Angle K, angle J. They're both 90. Angle K and angle J are congruent. They're both 90. Now I'm going to start looking at marks. Single little rainbow thing here. Angle L. Congruent to which one over here? Single mark. Is that you? Good. Double marks. Oh, shoot. KJ. I had some more 90s. Oh, N and G. And then I'm double marks. M and I. There you go. Angle M, angle I. So there's my 4 pairs of angles that are congruent. I need to go for 4 pairs of sides now. There's my 4 pairs of angles. I need to go for 4 pairs of sides. I'm going to start with single lines. Single lines. Segment NK. Congruent to. I think I'm going to call it JG because I just imagine that this second one would be flipped over. It doesn't matter. JG. I think I'm going to go with JG. This will help me to name over here, but I'm going to go with JG. Now let's go to double marks. K to L. K. I started at the right angle. Oh, yeah. G to H. Good. Hold on a second. I feel like I messed something up right here. I'll come back to that in a minute. K to L. You said G to H. That's the best answer. I got to fix something over here in a sec. K to L, doubles, doubles. Okay, now I'm going for triples. Triples. N to M, congruent to. N to M. Oh, that is 4. All right, so let's go with the 4s. N to M, J to I. N to M, J to I. I got to get my 3s now. L to M, L to M, H to I. Now I ran into a little snafu in my angles. A little snafu, messed it up. Snafu. A little mistake. I just did.
I know that, but don't say that. Just use your English.
So I'm going to go on. She wants to be in the video today. That's the thing. You hear this? Yep. Yep. And a K. All right. I just had to switch something. It's K and G. Can you please stop talking? Thank you. At this point, it's just wasting time. So I switched out the K and G. Because I realized when I first did it, I just said, oh, K and J, they're right next to each other. But you know what? If I actually think about how this figure is kind of turned, I had to go and change it to say, no, it's actually K to G that matches up and N to J. So I just made a change right there. So my angles I changed. Well, it matters because of the position. Because if I were going to, like, flip this figure over and, like, lay it on top of it, like, I could actually, like, take a... If I was going to flip the figure over and lay it on top of it, I would need that to be, so here is, I'm just using some tracing paper to show you what I mean. This is G, J, I, H. And if I'm saying these are congruent, then at some point I'm going to be able to flip it over, and actually I'm going to have to go like this. But you see now how it's the G that matches up with the K better? Okay. Good stuff. Now, I'm going to go through and I'm going to use what I have here to write my congruent statement. KLNM is congruent to, and I'm just going to go down this list. So I'm using the angles now to make the names. Before we were using the names to write the congruent statements for the angles. All corresponding parts are congruent to each other. Let's just simplify this answer. All corresponding parts are congruent to each other. And I gave all 8 of those pairs. You're going to want to use this as a reference to look back at, like, okay, what did it take then? Because this says, show that polygons are congruent. Explain your reasoning. Show that polygons are congruent. So I had to go through and list all those congruent parts and then make the statement that the figures themselves are congruent because all the parts are congruent. Now we're going to go on to 7 and 8. 7 and 8 don't have it's not as complex or as much to, like, you know, document when we go into 7 and 8, but there's still a lot going on. We have to find the measure of angle 1. And angle 1 is kind of in a funky place, I think. A little bit of a funky place. Oh, actually, can you guys look? Honestly, the way I was thinking about angle 1, I think I was making it. No, okay, we're on number 7 now.
It's not marked.
It isn't marked. That's just, and I was looking and I'm like, oh, did they mean that? No, they just mean this angle is the angle 1 we have to find. That's what I believe they mean right there. So, a couple things going on. I need to sort of break these triangles apart, and I'll show you why. Let me go and just highlight this triangle right here. I'm going to actually highlight it, and I want you guys to just, I know you don't have a different color, but I want you to duplicate it down here, A, B, C. Just jot it down here. Don't put any markings in it. Do we know the measure of angle A?
Nope.
You should. What is it? 33? Because it's got this mark and this mark. I am going to go with that. That's 33. Because it's congruent to D. There you go. How about angle B? What do we know about angle B?
Just a lot of steps.
It's 90. Yeah, we never said that this was going to be, like, easy money. We're not doing, like, middle school single-step problems. Angle B is 90. Jot that down. Angle B is 90. Because it's marked. Yep, 90 degrees. It's marked as a right angle. And then how do we find C? So what's 180 minus 90? 90. 90 minus 33. Is it 57? I think so. Does that seem right? Yeah. 60. Yep, totally. So that's 57 degrees. Now, let me go take this because I'm still like, all right, I got to get this angle 1. This is 57 right here. Now I'm up in here. How do I figure out what angle 1 is? Now I'm right back up into the figure. So this whole thing, how much is this whole angle based on this other triangle's drawing? 90. Isn't there a 90-degree mark buried in there? And what's the part of the 90-degree mark that we actually know? We just said that this angle buried in here was 57. So 90 minus 57 is going to get us down to what that remaining angle 1 is. 33? The measure of angle 1 is 33 degrees. The measure of angle 1 is 33.
So, like, you need to go through all of that?
Don't you? Yeah. I don't know how else to get at it. Like, I got to use both triangles, you know. I thought maybe because of the mark.
That's what I was looking at.
Yeah, well, oh, maybe it was. I don't know. Let's see how this one works out. Yeah, you're right, because we started out knowing that was 33. I wanted to say it was 33, but then I was like, was that mark just there because of the 1? Because I see it here, too. I bet you it means something. What do we need to, what angle do we need to go find to get at angle 1? And it's not in this bottom triangle. U. How are we going to get U?
Subtract. She's talking you to subtract 80 and 54 from 180.
180 minus 80.
Minus 50.
180 minus 80 is taking us down to 100. Minus another 54 is going to take us to, I think it's 46. And if angle U is 46, it's marked that it's congruent to angle 1. 46. Definitely not as painful as all the parts and stuff we had to do for those others.